So hey everyone, welcome back to my YouTube channel. I'm Sunny, your host, and today we are going to learn about numbers in Python. So till now we have already seen that what are integers, what are floats and complex numbers. But let's also talk about that how you can represent the large integers and how you can represent the large float values and scientific notation. So that's what new we are going to cover up here. And then we are going to talk about just a quick example of complex numbers. So there is nothing new here in this case because we have already covered it, but we will still see some examples. Then at the end, we will try to see that what are the different inbuilt functions available like ABS, that is absolute, div, mod, then power and round. So we will look into these inbuilt methods already available in Python, and also we will see that what possible use cases they might have. So let's start with the first examples, that is about integers. So let me show you some quick examples of integers, just a quick revision. So I have it ready here. So let's say we have x is equals to 4, y is equals to 0, and z is equals to -3. And if you try to print their values as well as that type of it, so you can see that I'm using the f string here. So let's try to run this and see the results. So obviously, as you can see that if you are writing like x equals to 4, y 0, and z equals to -3 without any decimal values, so this will be represented as integer, all of them. So integers are normally nothing but they are just whole numbers, right? So without any decimal values. So that's just the integers. Now let's look into the topic here that is about large integers, like how we can represent large integers and where it can be utilized. So when we talk about large integers, just think about examples like when you write currency, right? Let's take an example of currency. So let's say if I write, let's say $10 million. So I will write in this way, like either I will write this or you can even write just simple notation like 10 million. So this is how we normally see the currencies are written normally. But when we write in Python, so if you are a beginner, so you might be aware that yes, we can write them as just like that. But the problem with this approach is that there is a chance that you might forget any zeros, right? So in that case, you will end up getting wrong results. So in order to avoid that, what you can do is one thought will come into our mind that we can use this, right? So I will keep that as a last example, that is for Z. So one thought we that might appear in us that we can use commas, but the problem with the commas is that Python will treat it as a different data type. So let me show you. But as of now, what you can do is you can use, instead of commas in Python, you can use underscores. So whenever you will run this program, Python will simply ignore this underscores and it will treat this as an integer. Now let's try to see the outcome of this. So I will also comment the first one and let's run now. So as you can see that the first value is again same, but you can see the y value is also same and the data type is integer only. But when you look at the last one, that is where I have used comma, so it has changed to tuple. So tuple is another data structure that we are going to talk in detail, but at least you now know that avoid using this when you're going to represent a large number. So instead of commas, you can use underscores. So that is one way to represent the large integers in Python. And it is very handy when you are representing some large, let's say currency values. So in a same way, we can even represent the float values as well. So let's take in examples of float values. So since you all know that what float values are, so let's also take some basic example first of all. So if you want to convert these into float values, so you can simply write .0 here, or maybe you can use decimal numbers, let's say 3.3. So this is the example of float values. I think we have already seen it before. So just a quick revision here. Let's run this so you can see all of them are examples of float. Now let's talk about the large float values. So we will just simply pick up this value only. Like most of the time you will see that if I represent currency as an example, so most of the time they have decimal representation as well. So let's say you are talking about $10 million. So normally you can end up with zeros here, .00. And I am just removing this last example. That was just for the demo initially. Now let's try to run this and see the results. Or maybe what you can do is you can just see that, okay, what happens here. Let's say if I use the .00 also at the end, still you will see that the results. So you can see that it has converted the x and y into floats. But at the end, you can see that the last value is still tuple. So that's why I was saying that you can avoid that. Do not use the commas. Use underscore if you want to represent the large float values like that. Now let's try to also talk about the other representations. So we will talk about the scientific notations as well. So what are scientific notation? Scientific notation, actually it is used more oftenly in like subjects like physics and chemistry, where we are dealing with the large, extremely large values or extremely small values. So let's say if I talk about, let's say distance between Earth and Sun. So that's a very large value, right? If you just even if you convert that into kilometers or maybe into meters or whatever, so it will be very huge value. So in order to represent that into very concise format, so we normally use scientific notation. And similarly, if I talk about, let's say, radius of electrons or radius of an hydrogen electron, like let's talk about atomic physics here. So there you will see that the distance will be, it will be very, very small. It will be between 0 and 1 only, but it will be very, very small. So that is another example here. So let's take some examples and see that, okay, how you can represent scientific notations in Python. So I will take one example, like let's say x is equals to, maybe we will just pick some simple examples, let's say 12,000. So I will be using underscores here so that we don't make any mistakes. Now this is 12,000. Now let's say if I want to convert this into scientific notation, so what I can do is, first of all, I will try to bring this decimal place to the left hand side between 1 and 2. So this will become 1.2, and then what I will do, I will simply multiply it with 10, and also I will raise the power of 10 by 4. So why we are doing so? Because we are moving towards left side, and we are moving how many decimal places? 1, 2, 3, and 4 decimal places. So that's the simple representation of the same number x in scientific notation representation. Now let's say if I have to use Python to represent the same thing. So as per the previous discussion that we have done in the videos previously, we can write this as y is equals to, so since we know that 1.2 is there, right? And I can simply multiply this with 10, and then I will simply raise the power of 10 by 4. So that is the same representation, that is as y, but this is in terms of the number that I explained, that is 1.2 times 10 to the power of 4. But again, Python also gives you another shorthand way. So you can go for 1.2, then you can just simply use e, and then you can tell that what is the raised to power. So since I'm raising the power to 4, so I will write 4 here. So this is the same representation that I have shown you in y. Now let's see the outcome here, then you will get the clarification. Let's try to run this. So you can see that all of them are representing 12,000 only. So in Python here, in order to write concise code, so there is a representation that you can use like this. You can make use of this scientific notation representation in Python. Although we can try x and y as well, there is no restriction there. But this also sometimes makes your code concise and there is a less chance of mistakes. So obviously, like if you increase the number of counts here, or let's say a number of zeros here, so there may be a chance that you can make mistakes. So in order to protect that, you can use underscore obviously, but still this will be a very concise representation. So this I have shown you, this example is of a positive number. Now let's say if you want to represent a negative number, a negative 12,000. So you just have to make only few changes. So what I will do, I will simply write minus 12,000 and just add negative, and it will be a simple negative 12,000. So that is very straightforward. I think there is nothing new here. Now let's say instead of, since we have seen an example of very large number, right? So this is an example of large number, a large float value, which is far greater than 1, right? This is, and this example for this could be, let's say distance between Earth and Sun. This is an example of such kind of large float values. Now let's say if I have to represent the same, but for the numbers which are far less than 1 and greater than 0. So these are, again, they are still positive numbers, but they are very small number. So for this, the example could be, let's say radius of, and let's say hydrogen atom. Okay, so this could be an example of it. Now, so I will take the same example, but I will show you the results for, instead of this, I can simply write 0.0012. Let's say if I have to represent this number, so how I can do that, let me show you. So again, what I can do is I can move this decimal place to here. So now we are moving towards right. So I will simply write again now 1.2 times 10 to the power of. So in this case, since you are moving from left to right, so you can simply add the power of negative here, and this will be minus 4 since we are moving 12 decimal places to the right. So same representation what you can do here. Now in order to change this, I will simply add a minus sign here, and instead of plus 4, I will simply write minus 4 here. So let's see the outcome now and update the code as well as check the outcome. Just add negative signs and see the outcome. So see here, the outcome here says that all of them are having same number, that is 0.0012. All representation are same, but this the z value is actually giving you a more like concise representation. So see, Python ultimately going to treat all of them as this at the backend. But here for us, that is so that our job becomes easier to write such numbers in more concise way. So that's why it is provided. But like in most of the use cases, or maybe most of the problem statement that you will face during your lifetime or during your work, so you might not be using these numbers like more oftenly, but still it is good to know about them. Now, one more thing that I would like to add here is that it's not necessary that you can write in a same way. Like instead of small e, even if you use capital E here, still you will find that it will give you the same results. So let me run the entire code and show you. So the first three is, you can see that is coming from here, and the last three is again coming from the last three results, that is from this. So this actually represent the same numbers. That means either you write small e or capital E to represent the exponent value. It's totally fine here. Both is accepted in Python. So this clears the examples of float values and large float values, scientific notation, and integers. Now let's look into the quick examples of complex numbers. Now complex numbers, again, it will be useful for the people who are doing research or maybe who are involved into let's say core mathematical kind of stuffs. So there they will definitely end up using complex number, but again, it's, you will encounter them very less, because in my last years of careers I haven't used complex number into any production. So that's rarely you will use, but it's good to have that knowledge. Maybe you might come up with some project, part of a project where complex number is being used, but till now I haven't seen in my 4 to 5 years of career. So here are some examples of complex numbers again. So this is 3 plus 4j, as you know that this is how the complex number is represented. We have seen that detailed example in the previous videos, so we will quickly cover it up here. So first example is, again, it's a positive complex number. Second one is, like, you can call it as a negative complex number. It's in the fourth quadrant, as you can see. Both of them are minus minus signs. Then we have 1j, that means it is a pure complex number, or a perfect complex numbers, you can say, because there is no real part here, right? And 0j is actually, again, it's a, if I talk about mathematically here, so 0j is nothing but 0, so it should be treated as an integer, but, or a real number, pure real number. But here, as you can see, that it, since it's Python, so that's why a representation has been given to this as well. So it will always be represented as complex number. And then similarly here in B examples, B should be a proper, you can say, a perfect real number here, because again the imaginary component is totally 0, but if you just check the data type of it, so it will be always complex number. And if you're not able to understand this, it's totally fine. Complex number is not meant to be used in most of the regular application that we see around us. So let's try to run this code and see the outcome. So you can see that all of them are complex numbers. So that was a quick introduction again with the complex numbers. Yeah, but if you want to see the details of it, so we have already one video in the playlist which you can check. Now let's talk about the inbuilt functions and methods for the numbers in Python. So these are the most common ones. So we are going to talk about them one by one. So let's talk about the ABS. So ABS stands for absolute value. So let me quickly give you an example here. So I think you can recall it from your mathematical classes. So if you can remember, so let's say if you have -5 as a number, and when you take a mod of it like this, so what is the results? It gives you 5. Simple as that. And if the number is 5 is as it is, and if you again take a mod of it, so it will represent you the number as 5. So that's what the absolute does here. So it will make your negative numbers positives, and then positive, it will keep it as positive only. And if you can remember, so we have also seen this in the function classes. So this is nothing but it represents as, you can represent this as f of x is equals to mod of x. So this definition says that if the number is, you should return this as x. That means whatever you put here, it will be returned as it is if the number is, if x is greater than or equals to 0. And it will return minus of x if x is less than 0. Now let's look into this. What does it mean? So let's say if I have f of -5, so this will be mod of -5. So as per this definition, it satisfies the last condition. So what I will do, I will just simply, x value is what? X value is -5, right? And there is a minus sign outside it. So if I simply open the bracket, so it will simply give you 5, right? And if I go for f of 5, so it will be simply mod of 5. And now you can see that it is satisfying the first condition, that is this one. So I can write it as 5 as it is. So this will be my final answer. So that is how this absolute value works. Okay, so that is a quick introduction. So this quick mathematical session here. Now let's go back to the code part. Let's see that, okay, how you can represent the same thing. So since we have taken an example of x is equals to -5, so let's take that. And now let's calculate the result is equals to absolute of. So you can see that again, just like print function, it's an inbuilt function, and just pass x here. And now we can print the outcomes. So I have a print statement ready for this, again using f string, so that we can see that what was the number before and what is the number after, and then we will simply print the results. And similarly, let's also take an example of +5 as well, and you can run this. So you can see that it was -5 before, and after it has become 5. And in the next example, that is, if it is +5, so it will simply return the +5 here. So that was a quick introduction to absolute value. Now let's take an example of divmod. So divmod is nothing but it is a division slash modulus. That means we are going to get when we use divmod, so we are going to get the quotient value as well as remainder value. So let's see that what I am trying to convey here. So let's say if you have x is equals to 10 and you have y is equals to, let's say 3. So let me again bring back the pencil here. So we all know that, let's say if you have 10 as a number here, and when you divide that with 3, so it goes, let's say 3 times 3, so it will give you 9 here, and you will get 1 as a remainder, right? So that's not a perfect division here. So what you will get here, so this is what? This is quotient, and this is the remainder, right? So div mod will give you the same results. It will give you the quotient as well as remainder when you will divide any number. So let me show you that how it works. So we can again use this as an inbuilt function. So div mod, it takes the value of x and y, and it will return what? It will return the quotient and remainder. So now you can see this is again a perfect example of multi-variable assignment. So since div mod is going to return you quotient and remainder in the same form, like in the same, like first it will return quotient and then it will return remainder. Two values it will be returning you. Okay, it will give you two outcomes. So those outcome will be arranged in this manner: quotient first and then remainder. So if you print these outcomes, so you will get the value as what? You will get 3, 1. So let's see. So I have again a print statement ready here. So let's try to run this. So you can see that before I run it, so you can see also that we have x divided by y, again perfect use of f string here. X and y will be replaced is equals to, so it will give you quotient and remainder as it is, right? So let's try to run this and see. So 10 divided by 3 is going to give you quotient as 3 and remainder as 1. So that was a quick intro of div mode. Now let's also look into the cases where you can divide them. Like let's say if this is a perfect divisible, let's say if I go for instead of 3, if I go to 5, and if I try to run this, so you will see that quotient has got 2 and remainder as 0. So that means this 10 is divisible by 5 perfectly because remainder was 0. So like you might end up with some problem statement where you have to check if some number is divisible by another number or not. So in that case, you can quickly go for div mod. So here you can see that it is going to, since in this case, in the second case, the remainder is 0. So we can say that yes, 10 is divisible by 5. Perfectly divisible by 5. So similarly, let's say if I have to check for the cases of, this will be more common that you will find that, let's say if you have to go for odd even test. So what you can do is you can simply check here that, let's say if I have to check even number test. So you know that whenever I go for even number, so I have to just check that if the number is divisible by 2 or not. If it is divisible by perfectly divisible by 2, so we can say that it's an even number. Otherwise, we can say that it's an odd number. So let's try to run this and see. So you can see the last example, that is 10 by divided by 2. So that is remainder got 0 here. So that means we can say that 10 is an even number. Similarly, let's take an even or odd number test as well. So we will simply check for odd numbers test. So here, so see, in even number test, what we can say that remainder should be equal to 0. And in case of this, remainder should not be equals to 0. So let's take an example here. Let's say 9 is a number. And if I try to divide it by 2, so you know that it is not going to give you remainder as 0, it will give you remainder as 1. So that means we can say that 9 is an odd number. Okay. So this kind of problem statement you might encounter in your, like, various problem statement that you will get in your job. So that was a quick demo of div mod inbuilt function. Now let's look into the power inbuilt function. So power is a very straightforward again inbuilt function. So we all know that Let's say if I have x is equals to 2 and we have y is equals to 3. So if I have to get the maybe z value, so we can simply get, if I have to take 2 to the power of 3, so I will simply write x powers double asterisk and then I can simply get y here. So I can get the 2 to the power of 3 this way as well. That is one approach. Otherwise, what you can do, you can go for a power inbuilt function. So what power here? So p, so the first value is going to be the base. That means in this case, it is going to be 2. And then y is the second value. That is going to be the power. So let's print the outcome here and show you the results. So I will simply say that print x to the power of y is equals to z. So z is the results. So let's try to run this. So here you can see 2 to the power of 3 is 8. So that's the quick use of power inbuilt function. Now let's look into the last use case, that is of round inbuilt function in Python. So this is a very useful one which we are going to use it. So let's take first example that where we are not going to specify that up to what extent we want to do the roundup of a number. Now, but before that, let me explain that what I'm trying to say here, that let's say we have x is equals to 3.14159. Let's say this is an example here. So whenever we say that if I directly use round function here, so what it will do, it will simply get rid of this all decimal values and it will simply return me 3 here. But let's say if I say that I want to get the outcome as up to 2 decimal places, I want the outcome to be round up to 2 decimal places. So what I will do, I will simply check that till here. So what is this number? So this number is 1, right? So since this number is less than 5, so I will not increment the number before that, that is 4 here. So the result will be 3.14 simply. Okay. Now let's say if the number was, maybe let's say if I have a number like this, and now if I have to round it this to up to 2 decimal places, so what I will do, I will simply write 3.1, and since this, I will check this 6 number, and since this number here 6, which is greater than 5 or greater than or equal to 5, so what I will say, I will simply increment the number after that. So it will become 3.15. Let's take one more example here. So let's say if I talk about very simple example. So let's say we have 3.9. So when we say 3.9, so we normally know, right? So if we can also say that, hey, this is approximately 4. We say, right, like that. Why? Because 3.9, when we say 3.9, so it is very nearby 4. So we can simply approximately call it as 4. Now let's say if I write 3.1. So when I say 3.1, so we can say that, yeah, this is approximately equals to 3, right? We generally on whenever we talk also, or whenever we do measurements, so we can sometime we do the approximation. So this is the same thing here. Now when we say 3.5, so this is exactly in the middle. So what in Python happens, so let's say if I have 3.5, so it will simply, again, it will give you 4 here. So it has a rule there that says that if a number is 5 here, so since we can consider 5 near to, or it will be like upgraded, you can say. Okay, so we can simply increment the number before that. But let's say if it is 4, which is less than 5, so in this case, again, we can give it 3 as an answer. So I hope you have got the general idea that how this works in Python. So let me clear the board here and then let's run some examples. So it will be very straightforward. Like if you go for without specifying up to what decimal point you want to round off, so you can simply use like this. So round, again inbuilt method, pass the x value or the number that you want to round off, and we can just check the result before and after and see the results. So let's run this. So you will see that it was earlier, it was 3.14159 and now it is 3. Since we did not specify any value here that up to what extent we want to round off, we'll simply check the number which is here, that is 1. So since it is 1, which is less than 5, so it did not do any increment into this 3. Let's take the same results and let's take an example of, let's say if it is 3.9 here, and if I again run it, so you will see that it has made the increment here, that it made it 4 because that is nearly equals to 4. So that is the example of without specifying any rounding up to value. Similarly, if I have to check, let's take some more simple examples. So I was giving you an examples of single decimal places like this one, 3.9 again. So this will again give you 4 as an answer. See, now if I take the example of, instead of 3.9, let's take an example of 3.4 or 3.1. Let's say take an example of 3.1 and let's try to run this. So it will simply return me 3 because the number is nearly equals to 3 only, or approximately equals to 3. Now let's take an example of 3.5 here and run the example. So for 3.5, you can see it is becoming 4 because that is where it is drawing the line. That means 5 or above than that. So okay, it will simply increment, or it will round up to by incrementing. But if it is below 5, that is 4 or so, 43210, it will simply degrade the number, or it will simply not increment anything. It will simply drop it. So these were the examples where you are not specifying any like point where, or you are not specifying up to what decimal point you want to round off. That was a quick example here for the simple use case. Now let's see that, okay, if I specify the numbers here. So let's take an example of up to 1 decimal places. If I want to specify up to 1 decimal places, so what I can do, simply use round, and then after that you can just simply provide 1 here. So what it will do, it will round it up till 3.4. So here you see that before 4 we have we have 5, right? So the answer will be 3.5. Let's see. So before it was 3.45. Since I have specified that I just want up to 1 decimal places, so it will simply become 3.5. Let's take one more example here. Let's say we have 3 here and run it. So it's going to be 3.4 only, because 3 is less than 5, right? Similarly, we can also check for, let's say, up to 2 decimal places as well. And we can also look for 3 decimal places. So these are some more examples, and let's try to run this. So you can see 3.4456. Since it is two decimal places, so it is returning me 3.45. And similarly, we have this examples for first. Now, one quick note here, that let's say sometimes you might come up with a use case where you don't have to use decimal places, or you have to do some approximation. So let's take an example here. Let's say you have 3.6 here. Now there are, normally people will consider that if I convert this into integer, so it will simply give me 3 values. It will simply drop the 6, but that will not be a correct approximation. So if you are doing something where, or if you are doing some approximation, or where maybe it has to be mathematically correct, so at that point definitely do not go for integer or integer typecasting. Go for a round method simply, because that will give you a better approximation as compared to integer. So what integer will do, it will simply drop all the decimal values. So let me show you that what I'm trying to say here. So see, in the first case I'm using integer. In the second case I'm using the round method. And you will see that what is the results of integer and what is the results of round. So as per round, this is 3.6, right? And since we are not specifying any up to what extent I want to do the roundup. So what it will do, it will simply approximate this number 3.6 to 4. Why? Because 6 is more than 5. But if let's see the example of integer, you will see the difference here. So see, when we were using integer, so it simply dropped 6 and it has given 3 as an answer. But when you do round, so it is going to give you 4 as an answer. So whenever you're dealing with currency like problem statement, where approximation matters a lot, so in that case always go with the round inbuilt method. Do not go for integer typecasting. Okay, so that way you will build a better real world solution. So let me correct this. So the first one is a wrong way to round up, and the second one is the correct way to round. So that completes this session. So I hope you have learned something new today. And if you are already familiar with this, so I hope you have got a quick revision here. Okay, so see you all in the next session. Till then, keep on learning and keep on exploring. Thank you.